So for this experiment, I will be conducting a hypothesis test for two population means with two population standard deviations unknown and unequal. So based on research by the American Heart Association, nicotine increases blood pressure. In order to prove that blood pressure is higher in those who vape compared to those who don't, I have gathered data from 20 participants, 10 of which vape and 10 who don't vape. The mean average systolic pressure of those who vape is 144.6 with a standard deviation of 7.1. Those who do not vape have a systolic pressure mean of 125.4 with a standard deviation of 9.9. So I will test the claim that nicotine increases systolic blood pressure with a 95% confidence, assuming that both population distributions are approximately normal. So based on this information right here, we can find our populations. So our population 1 is those people who the sample size that consume nicotine, and population 2 is the people who do not consume nicotine based on the samples right here. So after we find the populations, or we can distinguish the populations, we can start our hypothesis by finding the hypothesis. So the null hypothesis will contain the presumed status of the parameter, while the alternative hypothesis will contain the research claim. So for the null hypothesis, we come up with the assumption that those two means are equal, but on the alternative hypothesis, the average systolic pressure of those who vape is going to be larger than those who don't. So that's going to be our alternative hypothesis. So for our second step, we are going to determine the distribution, which distribution we are going to use, and also we are going to determine the level of significance. So notice that we are doing a test for two population means. The population standard deviations are unknown. We were able to calculate the standard deviation for samples from both populations, but we don't know the values for the population standard deviation. Because of everybody's blood pressure are not the same, we are going to assume that a sigma 1 is not equal to sigma 2, and we will not be pulling S of 1 and S of 2. Because all of these, we are going to use the t-test distribution, and for a level of significance, we will be using 0.05, because level of significance is the same thing as 1 minus level of confidence. And also, we are going to assume, I forgot to put this, well, we are going to assume that this is a normal distribution. So now for step number 3, we will be looking at the appropriate statistics and calculate the test statistics. So for population 1, we have the nicotine consumers. For population 2, we have the non-nicotine consumers. So for population 1, the mean average systolic pressure for the people who consume nicotine was 144.6. Their standard deviation was 7.1 and the population sample was 10. For the population 2, which is non-nicotine consumers, we have the sample mean systolic pressure of 125.4 with a standard deviation of 9.9, and the sample size was 10. So once we have all these values, we can plug them into the test statistic formula, which is this right here. So this formula includes the difference of the x of 1 minus x of 2, and we take the difference in the population mean as well. So basically, we just take this formula and plug all that information in here, and we will get this right here. So we had to assume that mu of 1 and mu of 2 is equivalent to 0. And then after you do the whole formula, you should get your results, which my t-test statistics is 4.98 around. So for our last step, we will be deciding about the null hypothesis, and we are going to come up with a conclusion. So the very first thing I would do in this case, it will be to find the degrees of freedom, which it will be the smallest sample size minus 1. In my case, it was 10 minus 1, so 9. So I will look into the degree of freedom at 9 degrees of freedom and at the 0.5 level of significance, and it will be at 2.262. Then after this, I will check the rejection regions for hypothesis test, and I will see that I fall into the second sample, because my t value was 4.98 and the value of the 9 degree of freedom at the 0.5 level significance was 2.262. So this falls within the rejection region. So based on this information, we will reject the new hypothesis due to sufficient evidence at the 95th percentile level of confidence to support that nicotine causes a rise in the systolic blood pressure. And this will conclude my research.